Could Uranus moons harbor life? Exploring the possibilities of extraterrestrial existence. Uranus, the enigmatic ice giant of our solar system, has long remained in the shadows of its more famous neighbors, like Jupiter and Saturn. With its bizarre sideways rotation and faint ring system, Uranus is already unique. But what truly intrigues scientists are its moons. Recent studies suggest that some of Uranus' moons may harbor subsurface oceans, raising an exciting question. Could life exist on these distant, icy worlds? The possibility of extraterrestrial life has captivated humanity for centuries, and Uranus moons present a tantalizing opportunity to explore this profound question. As we delve deeper into the mysteries of these icy satellites, we uncover a story of potential habitability, scientific curiosity, and the enduring quest to understand our place in the cosmos. The mysteries of Uranus and its moons. A hidden frontier. Uranus is the seventh planet from the Sun and, despite its size, has remained one of the least explored planets in our solar system. NASA's Voyager 2 remains the only spacecraft to have flown past Uranus, providing brief glimpses into its complex system of 27 known moons. Among these, Titania, Oberon, Ariel, Umbriel, and Miranda stand out due to their size and potential to support life. These moons, named after characters from the works of Shakespeare and Alexander Pope, are not just icy rocks, but worlds with their own unique geological histories and potential for harboring life. Most of Uranus' moons are composed of rock and ice, making them similar in composition to other moons in the outer solar system, such as Europa and Enceladus. Given that Jupiter's and Saturn's icy moons are believed to contain subsurface oceans, scientists are now considering that Uranus moons might also have liquid water beneath their frozen surfaces. This revelation opens the door to the possibility of extraterrestrial microbial life. The presence of liquid water is one of the most critical factors in the search for life, and Uranus moons could be hiding vast reservoirs beneath their icy exteriors. Could Uranus moons have hidden oceans? The science behind the speculation. Scientists have long speculated about the internal structures of Uranus' largest moons. Recent computer models based on data from Voyager 2 and Earth-based telescopes suggest that these moons may have retained enough internal heat to sustain subsurface oceans. The idea of hidden oceans beneath icy crusts is not new, but the application of this concept to Uranus moons is a relatively recent development. The primary source of this heat would be the decay of radioactive elements within the moon's cores. Additionally, tidal forces, caused by Uranus' gravitational influence, could generate friction within the moon's interiors, producing additional heat. If these factors are strong enough, they could prevent the complete freezing of internal water, creating an environment where liquid water exists beneath the ice. This process, known as tidal heating, is also thought to be responsible for the subsurface oceans on Europa and Enceladus. Titania, the largest moon of Uranus, is one of the prime candidates for a subsurface ocean. Its size suggests that it could have retained heat for billions of years, allowing water to remain liquid beneath its icy crust. Oberon, slightly smaller but similarly structured, might also harbor an underground ocean. Even smaller moons like Ariel and Miranda, with their evidence of past geological activity, could have pockets of liquid water hidden beneath their surfaces. The secret to life in the outer solar system. What makes Uranus moons unique? If these subsurface oceans exist, the next question is whether they provide the necessary conditions to support life. On Earth, life thrives in extreme environments, hot hydrothermal vents in the deep ocean, acidic lakes, and even frozen Antarctic ice. If microbial life can adapt to such conditions here, it is possible that similar organisms could survive on Uranus moons. For life as we know it to exist, three essential conditions must be met. 1. Liquid water, a crucial ingredient for biochemical reactions and cellular functions. 2. energy source, required for metabolism and sustaining biological processes. 3. Essential chemical building blocks, including carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. If hydrothermal vents exist on Uranus moons, they could provide a steady source of energy and nutrients, much like those found in Earth's deep-sea environments. In these locations, microbes do not rely on sunlight, but instead harness chemical energy from reactions between water and rocks, a process known as chemosynthesis. This form of energy production could be the key to sustaining life in the dark, icy depths of Uranus moons. What type of life could exist? Imagining the possibilities. If life exists on these moons, it would likely be microbial, similar to bacteria or archaea found in extreme environments on Earth. These organisms could survive in complete darkness, relying on chemical reactions for energy. Some scientists speculate that if conditions are stable enough, more complex life forms, such as multicellular organisms, could evolve over time. However, the extreme conditions and limited energy supply make it unlikely that intelligent or large organisms exist on Uranus moons. Even the discovery of microbial life would revolutionize our understanding of biology and the potential for life elsewhere in the universe. It would confirm that life is not unique to Earth and could exist in many forms across the cosmos. The study of extremophiles, organisms that thrive in extreme conditions on Earth, has already provided valuable clues about the potential adaptability of life in alien environments. By studying Uranus moons, scientists may unlock new clues about the origins of life itself. Comparing Uranus moons to other icy worlds. Europa and Enceladus. Uranus moons are not the only places where scientists suspect subsurface oceans. Other icy bodies such as Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, have been identified as prime candidates for extraterrestrial life due to their liquid water beneath the ice. These moons have been the focus of extensive research and are considered some of the most promising locations for finding life beyond Earth. One major advantage of these moons over Uranus is that geysers have been observed spewing water vapor into space. This allows scientists to study their internal composition without landing. Unfortunately, no such plumes have been observed on Uranus moons, making direct investigation more difficult. Nevertheless, the potential for subsurface oceans remains high, keeping interest alive for future exploration. The challenge of exploring Uranus and its moons. Despite the promising potential of these moons, our knowledge remains limited due to the lack of direct exploration. Voyager 2 provided valuable but incomplete data, and no spacecraft has visited Uranus since its brief flyby in 1986. However, this could change in the coming decades. NASA and other space agencies have proposed missions to the Uranian system. A dedicated orbiter equipped with modern instruments could provide high-resolution imagery, detailed gravitational data, and even landers capable of detecting organic molecules on the surface. If a mission were to confirm the existence of subsurface oceans, it would be a significant step toward determining whether these moons could support life. The importance of studying Uranus for future space missions. Understanding Uranus and its moons is crucial for expanding our knowledge of ice giants and their potential for habitability. While missions to Mars and Europa have been prioritized, sending spacecraft to Uranus would provide a fresh perspective on how planets and their moons evolve in the cold outer reaches of our solar system. Learning more about these distant worlds could also help scientists refine their search for exoplanets with similar characteristics. How ice giants like Uranus could shape the future of space exploration. Uranus and Neptune are often overlooked compared to Jupiter and Saturn, but they hold key information about the formation of planetary systems. Studying Uranus moons can also provide insights into how water behaves under extreme conditions, helping astronomers understand whether similar icy moons around exoplanets could harbor life. The data collected from future missions to Uranus could influence how we design interstellar probes, space habitats, and even propulsion systems for deep space travel. Could Uranus moons hold the key to understanding alien life? A revolutionary discovery awaits. Discovering microbial life on Uranus moons would be one of the most groundbreaking scientific achievements in history. It would confirm that life is not unique to Earth and could exist in many forms across the universe. The study of extremophiles, organisms that thrive in extreme conditions on Earth, has already provided valuable clues about the potential adaptability of life in alien environments. By studying Uranus moons, scientists may unlock new clues about the origins of life itself. The uncharted frontier of Uranus moons, a journey worth taking. The exploration of Uranus and its moons remains one of the greatest challenges in modern space science. While we still have much to learn, the potential for discovering subsurface oceans and even extraterrestrial life makes these icy worlds an enticing target for future missions. If life does exist beneath the icy shells of Titania, Oberon, or Ariel, it would revolutionize our understanding of the universe and our place in it. The journey to uncover the secrets of Uranus moons has only just begun, and the next few decades may bring discoveries beyond our wildest imagination. As we stand on the brink of a new era in space exploration, the icy moons of Uranus beckon us to venture further into the unknown, to seek answers to questions that have puzzled humanity for centuries. The possibility of life beyond Earth is no longer a distant dream, but a tangible reality waiting to be discovered. The secrets of Uranus moons may well hold the key to unlocking the mysteries of life itself, and the journey to uncover them is one of the most exciting adventures that lies ahead. The universe is vast, and the potential for discovery is limitless. Uranus moons are just the beginning.